Hi everyone, and welcome to Smart Alex Coaching. In this video, we're going to look at how to solve inequations involving rational functions, the common mistakes most students make, and the correct way of solving them. Let's look at the correct method for solving rational function inequation. The question we have is solve the following inequation and represent the solution on the number line. Here we've got 4 over 2x minus 1 is less than 1 over x plus 2. When we solve inequations, one of the things we have to worry about is sign reversal. Remember that the inequality sign will reverse when we multiply or divide by a negative number or when we take the reciprocal of the fraction. So in order to avoid this problem, what we do is we multiply both sides by the square of the denominator. This is always going to be positive, so we don't have to then worry about the reversal of the inequality sign. So this is how we go about it. We multiply both the left and right hand side by 2x minus 1 squared, which is the denominator of the left hand side. We also multiply both sides by x plus 2 squared, which is the denominator of the right hand side. We then do some cancellation. We now have got 4 times x plus 2 squared times 2x minus 1 is less than 2x minus 1 squared times x plus 2. And once you get to this step, don't rush ahead and expand it because that's going to give you something really messy. I'm going to move the right hand side over to the left hand side. So now we've got 4 times x plus 2 squared times 2x minus 1 minus 2x minus 1 squared times x plus 2, and all of this is less than 0. We then use the factorization technique. So I'm going to factorize out the highest common factor. In this case, it's x plus 2 times 2x minus 1. And in another bracket, we multiply by 4 times x plus 2 minus 2x minus 1. And be careful, make sure you retain the bracket, and all of this is less than 0. We're then going to expand the expression within the third bracket. If we get x plus 2 times 2x minus 1 times 4x plus 8 minus 2x plus 1 is less than 0. And when we simplify this, we get x plus 2 times 2x minus 1 times 2x plus 9 is less than 0. So our original inequation 4 over 2x minus 1 is less than 1 over x plus 2 now becomes x plus 2 times 2x minus 1 times 2x plus 9 is less than 0. And in order to solve this, I'm going to be graphing this cubic and then read the solutions from the graph. If you've forgotten how to graph polynomial functions, I've also included the link to my previous video on the top here. You can click on that and have a watch of it as well. First, we need to identify the roots of this cubic, which is going to occur at x is equal to negative 2, x is equal to a half, and x is equal to negative 9 on 2. Once that's determined, we just do a quick sketch of the polynomial. Okay, the roots are at negative 4.5, negative 2, and a half. Now, the leading term of this polynomial is x times 2x times 2x, which is 4x cubed, which means that when x approaches positive infinity, 4x cubed is going to be approaching positive infinity as well. So this is where the graph will be heading. When x approaches negative infinity, 4x cubed will also be approaching negative infinity. So this is where the curve is going to be heading when x approaches negative infinity. Now all these roots are single roots, so you can just fill it in like this. Okay, and what we're looking for is we're looking for the section of the curve that is less than 0. Well, that's going to be the sections below the x-axis. So it's going to be those values here. And another thing that we pay attention to is that it is less than 0, which means that we exclude the roots, negative 4.5, negative 2.5. So from here, our solutions to this inequation is x is less than -4.5, or x is between 1/2 and -2. So to represent this on the number line, this is what it looks like. So I've got -4, -3, -2, -1, 0, 1, 2. So -4.5 would be somewhere about here, but we actually don't want to include that. So I'm going to make that an open circle. And also at -2 is another open circle, and 1/2 is another open circle. And then we just fill in those regions. So that's how you represent the solution to this inequation on the number line. Now that we've got the solution to our inequation, I also want you to understand what it means visually. So our original inequation 4 over 2x minus 1 is less than 1 over x plus 2 can be visualized as two graphs where one graph is less than the other. So what I've done was I used Desmos to graph these two functions. The first, the red graph is y is equal to 4 over 2x minus 1. This is a hyperbola with the asymptote at x is equal to 1/2. So the blue graph is y is equal to 1 over x plus 2, and it has the asymptote x is equal to -2. So when we're solving this inequation here, 4 over 2x minus 1 is less than 1 over x plus 2. What we're looking for is we're looking for values of x where the red graph is less than the blue graph. In other words, we're looking for sections of the graph where the red graph is below the blue graph. So looking at this graph in more detail, what values of x will make this true? Well, the first is this section between -2 and 1/2. So you can see here, between these two values of x, our red graph is below the blue graph. And another place where the red graph is below the blue graph is when x is less than -4.5. It's very tight here, but you can just make it out. And if we relate this back to our original solution, recall that our original solution was x is less than -4.5, or x is less than 1/2 but greater than -2. You can see that our solution here in fact corresponds to the values of x where our red graph 4 over 2x minus 1 is less than a blue graph 1 over x plus 2. Now that we've looked at the correct way to solve rational function inequation, I also want to point out the common mistake a lot of the students make. When a lot of the students see this question, they try to solve it like an equation. So what they might do is they might cross multiply and get 4 times x plus 2 is less than 2x minus 1, right? And then they try to rearrange the equation and they're going to get 4x plus 8 is less than 2x minus 1, or 4x plus 8 minus 2x plus 1 is less than 0. And then simplifying this, 2x plus 9 is less than 0. And then solving this, they're going to get x is less than -9 on 2, or another word, -4.5. And of course, whilst this is one of the solutions that we did obtain, by doing this, they actually miss out on the other set of solutions. I also want you guys to now understand this common mistake visually. When this rational function inequation gets solved like a linear equation without considering the sign reversal, we end up with this inequation, 4x plus 8 is less than 2x minus 1. And the way you visualize that is you can think of two straight lines. Here I've got the red line representing y is equal to 4x plus 8. The blue line representing y is equal to 2x minus 1. So in this inequation, what we're looking for is values of x, where 4x plus 8, the red line, is less than or below the blue line, 2x minus 1. And from this picture, you can see that that's going to be when x is less than -4.5, which corresponded to our answer that we got incorrectly. So as you can see, this is not the correct way to go about solving rational function inequation. Thanks guys for watching this video to the very end. I hope you did find it helpful and that you did learn something from it. If you did like it, can you please help us click like and share it? If you have any suggestions on how we can improve, please help us comment below. We upload videos weekly covering topics from Year 3 to Year 12 mathematics. So make sure you subscribe so you don't miss out. I'll see you next time. Thank you. Bye.